Welcome to today's lesson. This is for Tuesday, 9/22. We're looking at the notes for finding key points by hand. Now everything that's on here we've already done in some form or fashion. We're going to try to pull it all together. We ran these last week with just doing it on the calculator. Now that we have some skills with solving, we're going to be able to do this by hand. So we're showing the work about how to find those x-intercepts by hand. We do have one new concept, and that's identifying the vertex. So our notes, x-intercepts. An x-intercept always exists when y is equal to 0. So if you take the equation and set it equal to 0 the way that we have been doing the last several lessons and solve, those are your x-intercepts. Y-intercepts exist when x equals 0. So we're actually going to put 0 in for x and then simplify. The vertex is the new part, and it's a pretty simple equation. This doesn't always make sense to people, but what this is saying is that x equals negative b over 2a. So that little formula, which is kind of part of the quadratic equation, just without the square root, negative b over 2a, that gives you the x value of the vertex. And if you have the x value of any point, you should be able to plug that into the equation and find the y value. So let's see how this plays out. We have a volleyball player that hits the ball up and over the net with an initial velocity of 22 feet per second. This is the function that represents that, the path of the ball going over the net. And you have to show your work for all these, otherwise you're just doing it on the calculator, which we'll do it on the calculator, but we also need to know how to do it by hand. So the first thing I'm going to ask you to do is find the x-intercepts. And that's when you set the equation equal to 0. So I'm going to take this equation as it is, and I'm going to set it equal to 0. And I'm going to solve. Now, it doesn't look like this factors. We're going to find out that it does. Not all of them will factor, but this one seems to. So we're going to go ahead and solve this by quadratic formula, because I don't know if you would recognize the factoring here. So I plug it in. Negative 22, there's b squared, minus 4 times a times c, and all over 2a. So we have some simplifying to do. 2 times negative 16 is negative 32. That's easy. But inside, 22 squared is 484. 4 times 16 times 3 is 192. Notice there are two negatives in there, so that turns it into a plus. And when I add those together, 484 plus 192 is 676. Now the fact that this comes out as a perfect square, when you take the square root of 676, when you type this into your calculator, you get 26. So it's negative 22 minus 26 over negative 32, and negative 22 plus 26 over negative 32. But when you put this into your calculator to get those, it should come out pretty even at 1.5 and really negative 1/8, or negative 0.125, which is 1/8. The fact that this came out perfect as a perfect square tells me that this could have been factored. Here are the factors you would have used, and you would have gotten negative 1/8 and 1.5, the same answer that we got from quadratic formula. So those are my two x-intercepts. So right now, I'm going to go ahead and graph those. I don't know what my scale needs to be on the y-axis, but I do know that I don't need to go very far because my y-intercept is at 1.5. So I'm just going to go to 2 on the x and negative 1 on the x. And I'm going to plot my x-intercept at 1.5, my other x-intercept at negative 1/8. So I got those labeled now. Next thing we're going to find is the y-intercept, and that's actually should be pretty easy. If I put 0 in for x, 0 in for x here, 0 in for x. And when I say x, I'm obviously talking about t, because t is our x variable. Anything times 0, 0. Anything times 0, 0. It just comes out being the y-intercept is that constant at the end, 3, because these are all zeros. So I have a y-intercept at 3. And again, I'm not going to plot it yet because I'm not sure how high I need to go until I get the vertex. Those should be pretty easy. We've been doing parts A and B. So now let's go to C. How do I find the vertex? So we're going to use this formula for the x value of the vertex. So the vertex, we're going to start with the x value, or in this case t, and I do negative b over 2a. Negative 22, I'll write it over here also, negative b over 2 times a, negative 16. So that gives me negative 22 over 30, negative 32. Two negatives cancel to a positive. It gives me approximately 0.7. If you want to use the exact one, 0.6875, that's fine. I'm okay if you just round it to 0.7 on one like this. So I know where it falls on as far as the x value of the vertex, but I don't know how high it goes. I don't know that y value yet. So I'm just going to plug it in. I'm going to take my equation from the original problem, and I'm just going to put 0.7 in for x, or for t, and I just evaluate. You could also do this on the table app, and just go to type it into the table app, put in 0.7, and see what it gives you. So we're going to round that also 10.6. So my vertex is at 0.7, comma 10.6. So let's grab that guy, and we're going to go at 0.7. So this is 1, so 0.7's here, and I need to go up to 10. So I'm going to go by 2's here, although, I mean, it is just 10. You can go by 1's. So here's 2. So here's 3, my y-intercept, and 0.7, 10.6 would fall here. I do need to get one more point when I go to graph this. And so the only other whole number that's around here is 1. So when you plug 1 in, you'd find out that you get 9. 1 comma 9. And then you can use those points to draw the graph. Now it's harder for me to draw on this whiteboard, so I did take an image of what it looked like on my calculator, including that point 1 comma 9. So you certainly can be using your calculator to help you through this, and you know how to use GSolve, so you can do GSolve to figure out what the answer should be, and then just go through the work and make sure you're doing the work correctly. So here's the window I used, and here's what the graph looks like. And you should have that graph on paper. I just used the calculator to help us, as you can use the calculator to help you. A couple follow-up questions we have to look at. How long does the opposing team have to react before the ball hits the ground? Where it hits the ground is the x-intercept right here. Okay, so the ball's right here. They hit the ball, it goes up and over the net, comes down. 1.5 seconds is how long they have to react. Hit it up, boom, comes down. Okay, just over the net, a few feet over the net, and then comes down on the other side, maybe just a little bump over. 1.5 seconds to react. From what height did the player initially hit the ball? The initial height of anything, when you're talking about starting height, is the y-intercept. So we know that they hit it from 3 feet off the ground, up and over the net. If the opposing team wants to spike it at its highest point, as soon as I see this keyword highest point, I'm thinking vertex. So the answer to how high up do they need to reach to spike that down is the vertex answer. They need to be 10.6 feet high. So somebody has to be able to reach up pretty high there, okay? So we're talking college level volleyball. I don't know if I've seen any high school students that can get 10.6, their hand 10.6 feet in the air. And how long do they have to react to get up there? They only have 0.7 seconds to get up there after the ball's been hit, okay? So just putting these in context and answering those questions. You can go ahead and jump back in the live session if you have questions, or go ahead and start the homework.